morning, everyone. Nice to be here. So, my name is Edgaras. For the past 7 years, I've been working with observability engineering at Hostinger. And today, we will cover 3 stories. The changes in the past 10 years for the metrics infrastructure. Also, we will go to Woods to check the logs and migration to Loki. And we will cover also the introduction of the third pillar to observability with OpenTelemetry and tracing. So let's start with the metrics and evolution over the years. So 2016, no COVID, no big wars, so life is good. And we introduced Prometheus. Prometheus was doing node search. Chef was doing node search and updating Prometheus targets. Basically, it was done only once in 1 hour during the Chef client run. And we had nodes outside of Chef infrastructure that needed to be scraped as well. So we needed a central inventory to discover those targets dynamically. And of course, Prometheus configuration file was almost unreadable. It was like 300 or 400 lines. So 2019, we came up with console, integrating it as a scraped target discovery. But with this, there were some consequences, like dynamic targets resulted in more endpoints that needed to be scraped, and it of course resulted in more data growth. So standalone Prometheus didn't have any storage scaling, and actually to cover this, we were shrinking the retention from 1 month to 3 weeks, 2 weeks, and so on. And we were also growing a lot as a company. So in 2020, we decided to introduce long-term storage to the current infrastructure. The competitors were Thanos, M3DB, and Victoria Metrics. But since we were using virtual machines, M3DB looked like an easier option with less moving parts. So after started using M3DB, we of course observed that query performance was not good. Latency was too high for heavy queries. We also experienced like random out of memory errors, typical to M3DB at the time. In some cases, even segmentation faults. And the company was still growing a lot, so time series database was also growing. So to fix the performance and growth issues, we added additional aggregation layer, which downsampled all the metrics to 5 minutes. But with this, we still didn't have any high availability in collecting metrics. We had a couple of incidents where the Prometheus was hosted, with data center was actually down, so no metric scraping was done, and yeah, that was not very good for us. And the performance for the M3DB was still bad. So, 5th generation architecture came in 2023. So we actually introduced data center local clusters for M3 coordinators and M3 aggregators. So now we had like better high availability. We also introduced Prometheus agents. So there was no like central Prometheus that was doing the scraping. All the local Prometheus agents were scraping local exporter endpoints on each node, despite its Ansible node or Chef node or Kubernetes pod. But still, we didn't have any object storage support. Database was still growing, and like increasing the data size on the node was like bootstrapping new M3DB node, which took a lot of time. The storage was actually not very efficient and didn't have the M3DB didn't have at the time any compaction, it had some sort of compression, and we didn't have any cardinality stats, so we were kind of blind what we were ingesting. Also, the configuration was kind of complicated. You can tune a lot of things, but like there were no guidelines, so basically we did the trial and error method. And at the time, M3DB open source was dying. They were focused on the software as a service product. So we switched to Grafana Mimir. So going from 600,000 samples per second, now we are ingesting about 3.5, I think today I checked it, 3.5 million samples per second. We're running on 51 virtual machines, like 600 gigabytes of cache. We are running in 3 data centers as availability zones, but we still have single point of failure. It's the S3 or on premises backed by Ceph. Also scaling, because we are using virtual machines, scaling takes a lot of time, even if the process is fully automated. We also facing some inter-DC traffic issues, like managed to reach 20 gigabits per second from the backend to S3, got null routed by our internal network filter. Also, we are dependent on the public network, so sometimes we are affected by network latency, packet loss, which of course results in drop data due to buffer overflows. And recently we migrated from Grafana on-call to incident IO. Yeah, but actually it's cheap setup. It's very cheap compared to other offerings. Future. So of course we are planning to move fully to Kubernetes. So it's easy scaling. Depending on traffic volume, we can go with the replicas up and down. Also, we will introduce multi-tenant, so we can rate limit and get the statistics per each service, for example, in our case. We will also start using Kafka as an intermediary, which decouples read and write path, so heavy queries do not affect ingesters, and of course it absorbs sudden spikes in ingest volume. We will of course go with the fully microservice mode, so the scaling of each component will be easier. And the good part is private network, so we will not get congestions or latency or loss issues, packet loss issues. So it will result in ingestion done in time, because we are now facing like ingestion delay issues with the metrics. So that's it with metrics. Let's move to the woods and check the logs. Not real, of course, logs, the data logs. Yes, so we were migrating to Grafana Loki, and these are the challenges. So every team logs in like different format, so we don't have like no unified logging standard in the organization back at the time. So team X and team Y sends a log. One field has like integer, another is a string. So it gets to Graylog index. It gets mapped on the ingestion on the first log, and it's a good thing. But if the same structure gets like a different value type, for example string in this case, it's a mapping conflict in Elasticsearch, and this is nay, this is bad. Yeah, so we are like a small team at the time, only 3 person, so it was like hard to enforce consistency, and this mapping conflict resulted in constant log silently disappearing. So why log is god of mischiefs? Of course, Loki doesn't have any indices, so there's no like metadata and storage overhead. So cost saving, it's also cost saving. there's no like strict data types, so like it's easier new logging implementation for the developers. It has like all the Grafana products, like large community and well-maintained Helm chart, and of course we are running it on Kubernetes in distributed mode, but of course with that complexity also grows. It also supports S3, so like storage is mostly infinite. At the time, Greylog was backed by Elastic, not OpenSearch. That's why object storage feature for Elasticsearch was locked behind enterprise license. So that was one of the things that pushed us to lock as well. And we had already running Grafana Mimir with the alert manager, so the integration of the Loki ruler with the existing alerting pipeline was kind of easy. Now we can talk about label strategy that we chose. It's like one-fits-all label strategy is not working. Like we can see two queries. One is querying container query, for example Loki query, and another one is container Apache. So in first case we are processing about 100 gigabytes, and in another case we are processing about 2.5 terabyte of data, and this will result, I think, in a lot of network. So it's not we didn't even consider it to run on premises, because we didn't have such network infrastructure. And if you are querying it like 7 days back, this will get even bigger data volumes, about 25 times. Yeah, so changing systems is easy, but of course, like, people build muscle memory around tools they use daily, and trust in tools is built over the years. New tools, like, initially mostly feel slower than your old ones, and like rebuilding confidence in new platform takes like much longer. We also, when we were migrating to Loki, we did parallelization of the logs, so they were sent to the old stack and the Grafana Loki simultaneously. Why we did this? Because there were no tools to automatically migrate dashboards or alerting rules from Greylog to Loki. Yeah, so teams like also needed historical data in both systems simultaneously, and of course, like, observability systems are critical infrastructure, so we must avoid any interruptions to the logs. Auto-scaling part, like, we are running on Kubernetes, but the tricky part is like how to make query perform well without hundreds of pods like on standby. So during the day, so you can see those spikes, like work hours, queries must be fast, so running lots of replicas, it's not a problem. But during the night, like, low queries, running many pods are wasteful. But we chose like to auto-scale for peaks, but keep the baseline for reliability even if it's burning the budget. So the initial query can be fast. Okay, let's move further. Cache. Yeah, cache is a crucial part as well for the performance. So the problem is, like, memory is very expensive and you want to cache as much as possible. So you can see that 1 and 3 arrow is like memory is growing, and even cube eviction might start happening. But solution we came up with locally attached fast SSDs. So on the heavy queries, everything is offloaded to disk. So we have terabytes of cache now in production. This is kind of would be not possible or very expensive with memory. So 2024, 7 terabytes S3 storage, 5,000 lines per second, 200 gigabytes of memory. Vince looks impressed. We are growing steadily, and 2025, 150 terabytes S3 storage, 1,000 lines per second, and 500 gigabytes of memory. So, and now we are have 500 terabytes S3 storage, 300,000 lines per second, 1 terabyte of memory. I think Vince will go nuts this year probably. Yeah, traces, the last part that we will cover today. Introduced only last year, and actually we as observability team were pushing it instead of the third-party solutions. Yeah, so how we do the instrumentation part? Of course, we used auto instrumentation. Let's see how that goes. I will not go into detail what tracing is today. You are probably familiar with it, but this is how we implement it. So we are running agents in Kubernetes as daemon set. So they are running on each node close to the application, small resource footprint. We are also running gateway deployment collectors used for sampling, creating span metrics, and data transformations. And of course, as we are familiar already with Grafana products, we chose Grafana Tempo as tracing database. So as you can see, all the traces from the application are sent to local collector agent using OTLP receiver. Then they are processed if it's needed and sent through the OTLP exporter to the gateway deployment, which is doing sampling, creating metrics and transformations. How do we do the injection part? We have our custom Helm chart, which adds the OTLCR manifest, and the OTL operator injects the init container just by adding the environment variable. For PHP, we have our own OpenTelemetry PHP SDK wrapper package, which holds all the dependencies. So, yeah, it also does the pod spec mutation actually, and adds then the environment variable on application startup. So after enabling instrumentation, how it went, you would ask? Mainly fine. But we had these cases where process command attribute was like URL part of some request. So trade-offs of using auto instrumentation, I guess. How we are reducing cardinality, like in previous case. So high cardinality results in large responses, slower queries, and of course hitting limits. Since we are using auto instrumentation, it's cheaper to drop unnecessary data on the gateway collector, but of course it's best like to check the your instrumentation SDKs. Maybe it's possible to turn it off on the source side. Resource attributes, of course, should be bounded, like define boundaries. For example, HTTP status code is a good example. And reducing the cardinality in some cases even like avoids leaking secrets. For example, command arguments. There's a like I think an open issue, you know, in OTel repo that recommends to drop these specific attributes. Sampling. We are doing like basic thing. we are sampling successful traces at 50% and we keep all the error ones. So you should also decide if you're choosing how to sample it. So decide it tail sampling or head sampling. Like head sampling decides to keep or drop the trace at the start. It's like low overhead. But tail sampling requires each collector to have the full view of the trace. It requires more memory, of course. And otherwise the trace could be fragmented. I recommend to start with the basics, keep it simple, and of course test your sampling rules if they actually work. About the metrics that we are also generating in the gateway collector, I recommend adding expiration, because by default, if your application does not emit any spans, metrics will still be exported. So you would have stale metrics that would waste resources. And don't get too enthusiastic, of course, with dimensions, because each unique combination of dimension values creates a new time series. I would also recommend bounding buckets to real use cases, for example, for SLO. So you would not add unused bucket to your metrics. And of course, the span metrics should be done before sampling. So the statistics: 40,000 spans per second, 40 terabytes object storage, 24 cores, 30 gigabytes of memory, and 100 gigabytes of cache. And you would ask, where's the I? I excluded it because it would just generate more logs. Just joking. We are running MCP, which connects observability backends, Loki Tempo, and Mimir, and Kubernetes for rich context. And actually, we have our in-house assistant, Slackbot. And recently I was investigating why temper compactor pods are crashing. I just asked it. And interesting thing is that he helped me actually to fix it. He provided me the root cause and the fix. And actually, it was fixed in a couple of minutes. So, thank you for listening to me.